Hello, hello, hello. We are back. This is our input function, and this is where I left yesterday. So, input functions. You were in function and in a subtopic closure. Inside that, we were studying about input functions. All right, so we'll start. So, input functions. Since closure may be used, since closures may be used as arguments, you might wonder if the same can be said about the functions. And indeed, they can. If you declare a function that takes a closure as a parameter, then any function that satisfied the trait bound by that closure can be passed as a parameter. So over here, we are defining a function which takes a generic f argument and bounded by a fn, not fn once, not fn mute, fn, all right, and calls it. So we are calling, this is a function called call me, which has a generic f, which is of type fn. And then we are using f buffer to give a type f. And inside that, we are calling the f function. So that's what we are doing when we are, creating a closure. And inside call me, we try to call that closure and it gets called like this. That's what closure is. It looks like function, but it is called like function. It does everything like function, but it doesn't look like a function or sort of a lambda function, something like that. Then there is another function that we have declared that is going to just print I am function, very simplest form of function. And then inside main, we are saying there we shall make a closure. This is a closure, two pipes, and after that it will capture the value of print ln I am a closure. So it will capture I am a closure and it will store it in closure. So as soon as you run closure like this, like say closure, yeah, what should you see? I hope no errors. Yeah, it's an error because of semicolon. So as soon as you call the closure, which was this, which had a closure which was capturing the value of println I am a closure. So now it prints I am a closure. If it said something else, x plus y, it did something with it, took some value like function, operated on it, and passed it out. So that's what we do. Like it is exactly like function, but doesn't look like one. That's it. And we have to store that function's return value or anything in this in any sort of variable. Otherwise, how do you call a closure function? It is not a function that you can call anywhere. You have to have a variable names. So this is clear. So when we are calling the call me, we are doing the same thing over here. So we saying closure and then we are no opening it like a function or calling it like a function. So that's what happens over here. And when we say call me and function, we pass this. This is also doing the same thing, but now this is a function, but this was a closure. Sorry, this is a function, but this was a closure. And this function was just, calling both of them one at a time. So this is a closure, this is a function. When we run that, we get I am a closure, I am a function. That's it. Yeah, see? So you can do the same damn thing that a function can, but why make a function when you can just create a shorthanded closure and operate on it? Like call it and I guess edit it or return a value from it. So things like that. As an additional note, the fn, fn mute, and fn1 traits dictate how closure captures the variable from enclosing scope. So this is its scope, I guess. And these are two pipes which act as a closure or sort of we will capture you sort of way. Huh. So How closure will capture the variable depends on these fn mute, fn, and fn1 states. So that's what it's telling me. Let's move on. Now, as an outer parameter. So as an outer parameter, closures as input parameters are possible. So returning closure as output parameter should also be possible. Yeah, like functions too. However, anonymous closure types are by definition unknown, so we have to use implementation IMPL trait to return them. So we have to implement our own sort of ways how closure will give us a type or define something that is unknown for now. The valid traits for returning a closure are, so there is fn, fn mute, fn once. Well, we know some of them, we don't. We try to understand it, but we really don't understand it right now. We'll do. With time, we'll do. And beyond this, the move keyword must be used with signals that all capture occurs by value. And this is required because any capture by reference would be dropped as soon as the function exited and leaving invalid reference in the closure. So let's see. We are using, beyond this, we are using move. So beyond these, fn, fn mute, and fn once, beyond these, we use move keywords, which moves the ownership. And it must be used by with signals that all capture occurs by the value. All right, something is important over here. Now this is required by because any captures by reference would be dropped as soon as function exited, leaving the invalid reference in a closure. So we will see and try to understand it using this code. So there is a function called create fn, which I guess will create a function. So it returns what? It returns an implementation for fn, which looks something like this. Let text is equals to fn.to owned. All right. And then we move whatever closure we are trying to capture. So over here we are capturing this is a and text, but text should be owned by fn. That's what we are creating this implementation for. Now we are creating the implementation for fn mute also, doing the same thing because we want them to own it, the text. Otherwise, if let's say text gets out of the bound or something like that, let's say it goes out of the scope or gets dropped, then this closure will have some sort of error. That's why we are using move to move the ownership of the whole damn thing to a variable we'll call it to. So these functions are being called by some variables. So we'll, assign all these values and closure values in this variable. That way, let's read it again. Like beyond this, the move keyword use must be used with signals that all capture occurs by value. This is required because any captures by reference would be dropped as soon as the function exited, leaving invalid reference in a closure. Now I get you. Now I get the point. So now we are doing the same thing for fn1s, implementing fn1s, and then let text is equals to fn1s dot to owned. Now we are owning it. Then we use move keyword and then closure. It is capturing whatever is over there, which is this is a text, whereas text is fn1s to owned. Good. Now inside a main function, we declare variables and call functions and get a return value from these functions or a closure functions, I guess, and store them in these variables. And then we call these variables or sort of a closure function, like calling a function. So we are calling them. So we get something like this is a function, this is a mute, this is fn once because of these. What if I just try to call this create f once without anything? Because it is also a function in itself. So can we do that? F none, fn once. Oh, call it like a function, nothing happens. Because what is owned by what? Like, there's no point in doing this since nothing happens. Shall we move on now? Right. Now we are at examples in standard. Standard what? Standard library. So this section contains few examples using closure from the standard library. There are few closures written in standard library, and we'll be using them as examples, I guess. Hmm. So there's iterator any. So iterator any is a function which, when passed an iterator, will return true if elements satisfy the predicted predicate. If element satisfies the predicate, what is that? Otherwise false and its signature. So there's a public trait which is iterator, and then type item. Inside that we are calling we have a function clear. Yeah, a function declared called any, which has a generic f and taking a reference of mutable self, making a buffer f which is of type generic f, and returning a bool where f is fn mute, which takes self item and returns bool. If Let's read their comments to understand it more. So the type being iterated over is, type item, but type was used to sort of aliasing. So what are we aliasing item for? Is it alias for iterator or what? What is this item aliasing for? A type is used in some other context over here. Any takes the mutable self or the reference of mutable self, meaning the column may be borrowed and modified but not consumed. Any takes the ampersand mutable self. Any. Yeah, this is any. So, and modified but not consumed. All right. So fn mute meaning any captured variable may at most be modified, not consumed. And self item states it takes arguments to the closure by value. So if there is a f generic type which is defined as fn mute, which takes the self and item and returns a bool. So the self and item states that it takes argument to the closure by value, because this is a trait of iterator and we are using it. So let's see the main function. So in main function, there is vector 1 and vector 2. Vector 1 stores 1, 2, 3, whereas vector 2 stores 4, 5, 6. And then iter for vector yields something like ampersand, which is reference of I32, and destructures to I32. Yeah. So when we try to print it, so we print 2 in vector 1, and then we try to iter over vector 1, and then we use any function which takes the x. If x is equals to 2, then we get the index of x, and we get the 2 in vector 1 is at index of 1. That's what we get. We get true. Any returns boolean. So yes, it obviously gives us true. So 2 in vector 1. So if it is present there in vector 1, which we are iterating over using x, and we are taking it by reference. So if it is present, we'll mark it as true. If it is absent, let's say instead of 2, how about make it -2? Now let's run it. It should give us false, false. So this yields false value right now. But let's make it true and let's try to understand what we are doing over here. So we are iterating over vector 1 and then we are using any, this any function in which we are passing a closure which is, reference of x. If x is equals to 2, it is comparing if x is equals to 2. If it is, then we get a value of true or false and that's getting returned from there. And that's what we are printing. Now there's another way, which is vector 2 dot into iter any. So we are now in vector, we are checking for 2 in vector 2 and we see instead of iter we use into iter. So iter for vectors yields ampersand i32 and destructures i32, whereas into iter for vectors yields i32, no destructuring required. Very good for us. So instead of taking ampersand x, we directly take x because it is i32. And we are checking if x is equals to 2 in any form of vectors or any sort of elements present in the vector. If it is not, we return false. So we get a false. That's it. So instead of using iter, we'll use into iter and then we'll use any. Inside that, we are not taking x by reference, we are taking x as x, like i32, and x is equals to 2. Now, iter only borrows vector 1 and its elements, so they can be used again. So now we can use, iter again. So let's say we are trying to print vector 1's length. It is valid. And first element of vector 1 is, it is valid, so it will print 1. No problem there. Into iter does move vector 2 to its elements, so they cannot be used be they cannot be used again. But these are numbers, no, so they get copied. So what's the problem? So if we try doing it with, println first element of vector 2 is this and vector 2's length is this, we will get into some sort of error that we'll see in a moment. We'll uncomment these two lines and we'll see the error. Now, there is a let array and we are doing the same thing. We are iterating over array and we are seeing any and reference of x. If x is equals to 2 in that array, we say array has a 2, like array 1 has 2, so it's true. Whereas array 2 doesn't have 2 in it, number 2, so it's false. But for array 1, we are using array.iter. For array 2, we are using array.intoiter. And inside any function for array 1, we are taking it by reference because iter does give us, something like reference of i32 and we have to destructure that. But when we use into iter, we don't have to destructure anything. So we directly use x and we compare it with 2. Now let's uncomment the above line. Let's see what sort of errors do we get. Can we resolve it? So we get an error saying move occurred between vector 2 which has a type vector i32 which does not implement the copy trait. Well, vector does not, but the number inside it does. So it says that vector 2 into iter is vector moved due to this method call. I don't know what that method do. So it's probably using that vector and moving its value inside it and then destructuring it bit by bit inside it, then just giving us the destructured format and consume the vector at the same time. Now it says on the 14th line, there is a first element of vector 2 is vec to 0, and it is saying that value borrowed here after move. So we can't show you. It now starts to give me 310, which is not in our code. So it's, into it a function, and it's declaring self and has a return value of self into it. And it says you can clone the value over here, then it'll work. So instead of just passing the, vector, how about we pass a clone? That's what it says. Now it should work. It doesn't. Where is Intuitor? Shit. Huh. Sorry. Now it should work. Yeah, it does. So now we cloned the vector2 and passed it into Intuitor. And then we are sort of consuming that clone and passing out the value or giving out the value, which is already destructured. So we are passing out I32 directly, no reference of it. And we consumed this clone. Good. So as soon as that happens, we can normally call our vector1, vector2 element and their length. Otherwise, we would have some sort of problem. Now we get the point. We shall now move on. There's a standard iterator any. We'll see that somewhere. So this is any, exactly like what described to us, where where self is sort of sized and f is fn mute, which then returns a boolean value. Basic usage. That's one. That's what we know. This is array. So sort. Why are we using not a? What does this give us? It's asserting that if not a into it, and we are saying if x is greater than 5, there is no x is greater than 5. So it'll not happen. So it'll say probably that you were correct. There is nothing like x is greater than 5. We get a standard error. We don't see anything happening. All right. I'll just pause it for a minute. So we don't understand this line yet. As for what happens over here, well, x is greater than 0, so all of them are greater than 0, so it will be true. And the assertion will not show us any sort of problem, but this will, probably will. Well, we just copy it and by pasting it over here. There shouldn't be much of a problem. And both assertion blocks. My assumption that this is a not inside assertion was true because we don't see any sort of problem. So that's what happened over there, there also, but you were unfamiliar with it, so we thought it was some sort of error. Now let's move on. Iterator any is done. This is exactly how it looks. Instead of type item, no, it was not type item, it was something like size. Over here. Size is sized. Let's go at the top. Oh, what- oh yeah. It was like size sized. And then FN mute. But it is like type item and then directly any FN mute over here. Let's move on. So we are now searching through iterators. So iterator and find is a function which iterates over an iterator and searches for the first value which satisfies some condition. If none of the values satisfy the condition, it returns none, its signature. So there's a public trait iterator and type item, and inside that we have implemented a function which has a type generic p and takes the mutated self reference. So self mute reference and has a buffer predicate which is of type generic p. It gives us a option which has self item, self and item. What is item? Item is over here, where p, which is generic type instead of f, is now fn mute, which is a reference of self item and will return a boolean. So let's see first of all, and this is another one. So let's see there is a vector 1, which is again 1, 2, 3, vector 2, 4, 5, 6. We are just iterating over it using iter. So we say mute iter and then vector 1 dot iter. Now it yields or something like uses ampersand i32, whereas this just directly uses i32 and consumes this into iter. The vector 2 gets consumed. So vector 2 gets consumed over here. Then we see something like iter for vector yields reference of i32, and we want to reference one of its item. So we have to destructure i32 using ampersand i32 to get i32. All right. So find 2 in vector 1. That's what we are printing. And we are printing it in debug mode. Then we are using that iter variable, which is using vector.iter. So we can directly write it like over here. And then we are using a find, which is a new sort of method function. I don't know. And inside that we are passing a closure which is taking getting the element of reference of i32. So it has to be ampersand x, and then it is comparing whether x is equals to 2 inside the vector 1. If it is, it returns true. If not, it returns false. But what this find is doing, I don't know. Let's see the result first of all. This is first statement. So dot find is like returning an option like this option. So it's returning an option. So, oh, this is the find. Yeah, this is declared as find. So we are returning an option with self and item. So self is, let's say, sum, and then item is 2. There is 2, then we return 2. If there is none, we return none. If there is again 2, we return 2. If there is none, we return none. Now it works. Find 2 in vector 2, we know. It will consume it, but we know that it will find it with little bit of reference. Like we are using ampersand x to get to the element. So it says intuiter for vector yields. Intuiter, which was a method or function, for vector yields something like I32. So vector becomes something like I32, and we want to reference one of its item, only one of its item. So we have to destructure I32, ampersand I32 to get I32, the real one that we want. So we are using ampersand x, and then we are comparing it. And if it does return it, then we show it with some value. If it doesn't, we show it with none. So vector 2 does not have a 2, so we show it none. Same with array, we are doing the same damn thing with array. We're using find ampersand x for iter, and we are comparing it with 2. There is 2, so we'll return like some 2 over here. And if it doesn't has 2, so we'll return none true. But let's say if it has 2, so this will just return it has a 2, some 2, over here. This has a 2. So this thing which has ampersand x and comparing x is equals to 2 is working fine. There's no problem with that. Implementation is perfect. Now we go something like iterator and iterator and position. So iterator find gives you a reference to the item, like this was iterator find, and now we are at iterator find, which says that it gives you the reference to the item, but if you want the index of them of the item, use something like iterator position. So it will give you the index of whatever you are finding for. So we are doing the same thing over here. We have a vector. We have a variable called index of first even value, and then we are using vector dot iter over position, so that we use position of ampersand x, because we are using it as iter. So we should at least use double ampersand, something like this. But we want index, not the element. So we are using ampersand x. And then we see like check for even number. That's what we are doing. If index of first even number. So if x is even number, we get a 0 if dividing by 2 as a remainder. Then we give that x back. This is the statement. Then we are asserting some equality, like index of first even number. Does it occur at some value at 5? Let's see, 1, 0, 1, 2, 3, 4, 5. Exactly. So this will be true, so we'll not see any sort of, error message. No output means it is good. If you make it like something like 51, well, yeah, we're going out of bound, but it'll say LHS is equal to RHS failed. It failed. Left return something like some 5, whereas right had some value of 51. So they are not matching. We know. Now we use intuiter to do the same thing. No, we use intuiter to index of the first negative number. So there is none. So we say that index of first negative number is none. Use intuiter, so it'll probably just consume this variable. So after that, we won't be able to use this index of first even number again, even if we try to. Let's copy it. Copy it. Let's go sort of above it and try running this. We should get an error. We get an error that intuiter moved this vector. So while using intuiter, we were using it on same vector. So it sort of moved that vector after using it. That's what it does. It consumes it. Then for position, we were, making a closure which has a x, and if x is less than 0, which is negative, then we'll return that to, index of first negative number. But since there is none, we get a value of none. If there was some like this, let's say -9, and we are implying that it has none, we'll get a LHS equal to RHS wala error sort of telling us that our LHS is not equal to RHS. So left returns some index of I, some index of 1, because 1 is now -9, whereas right returns none. Good. Now it tells me to run backtrace and all that. So it tells me to, see, find map and position and our position, respective position. What is our position? And these all are methods. All right. Inside the trait called iterator and standard iter. So high order functions. We have high order functions. So we are inside examples, no? No, closure is done and all the examples of standard is done. So now we are back to functions. So now we are creating high order functions and then last is diverging functions. Let's see. Oh, so high order functions. The Rust provides a high order function which is called shortly like HOF. These are functions that take one or more functions and or produces a more useful function. So HOFs and lazy iterers gives Rust its flavor, its functional flavor. Well, let's see and let's taste that flavor. There's a function called odd or is odd, and it gets a value of n which is of type U32, returns a boolean. So if n is divisible by 2 and we get a remainder of 1, it means it is odd. If we get a remainder of 0, it is even. So we are not creating is even because whatever is not odd is even. All right. So now we are implementing that in a main function. So inside main function, we are saying print ln and find the sum of all the numbers with odd square under 1000. So let upper is equals to 1000, and then imperative approach would be something like let mutable ACC or accumulator declare accumulator variable be a 0 for now. So we have a upper variable and then we have a mutable accumulator variable which is 0 for now. And we are trying to find the sum of all the numbers with odd squares. Squares are odd under 1000. All right, so we are squaring that number, and if it is odd, we are adding that. Shade. What will we? Will we get something interesting? Eh, only 5456. How about we increase that? Two more zeros. Does it have a pattern or what? 52593030. So we have a function that is checking if it's odd, whatever the number is passed through it. Then we are printing sort of, find the sum of all the numbers with odd squares under 1000. Then we are doing sort of imperative approach. Then there is another approach which is functional approach. So this is functional approach and this is imperative approach. So let's see imperative approach first. And what does that mean? Uh, there's AI also. What does mean by imperative approach? VRICH approach. These are two different I so these are two different programming paradigm way of thinking about and writing codes. Imperative approach tell the computer how to do it step by step. You write explicit instructions that changes the program states over time, uses loop conditionals and variable mutations. Focus is on the process. So if there is a number like 1, 2, 3, 4, 5, and there is a total of 0. So for n in numbers, which is total plus or equals to total is plus n, which is mutating state, we'll print total. So we are telling it step by step that we want to get a sum of list. We are not using any sort of function. We are creating total. We are adding the sum to it. This is wrong, I guess. If you want to assign total to the value of total plus n, we shouldn't be using either plus or we shouldn't be using the total over here. But what we are doing over here is we are saying we will add total plus n and we'll assign it to what was total with addition. So we'll add this to a total again. It becomes something like total plus n. So what the hell is this? It's wrong anyways. Functional approach. So it tells the computer what you want, not how to get it. So I just want a sum. Tell it I want a sum of all these arrays, sum of numbers, and a reduce. So if I wanted to reduce it, I would. And then inside total, I'll just print it. So quick comparison. Focus is in imperative how to do it. In functional, what to compute. The state will be mutable changes. In functional, there is no mutable, so it is immutable changes. So I think functional will be preferred most of the times if we are not implementing the lower level details. Side effect would be like imperative is very common. Functional is avoided. Why? Why? Readability. So imperative is more verbose. Functional is more concise. So if you know the function, you can make it more concise and understand what it means. If you don't, well, you should go with imperative. Examples looks like something like G, C, Java, Python, oops, whereas functional, Haskell, Lang, JS, all that. In short, imperative is like a recipe with step-by-step instruction, while functional is like a math formula, right? Well, I'll tell it that you're doing total plus total equals to null. Total plus equals to total. I don't know what sort of AI model is it using, because sometimes it use something good, sometimes it doesn't. OTA. It used Claude Sonnet. Shit. Claude Sonnet, which one? You're absolutely right. So yeah, this should be it. Not total plus equals to total. Claude can do this sort of mistake. Well, I didn't expect it. Claude said, I'm what? Alright. So now we shall see the imperative approach to find the sum of all the numbers with odd square under 1000. So we are first of all creating a accumulator variable which will sort of count it, I guess. Whenever we find something, we add it to accumulator and later we return the accumulator. Yeah, we are returning or printing that accumulator. So iterate over 0, 1, 2 to infinity. Not infinity, I guess. So yeah, iterating till infinity. What the hell? We just want to find, the upper. So Oh, so if it is upper, we are breaking inside that. But over here, we are going to infinity. So why not use just a while loop? All right, loop is loop. So for loop will do the same. While loop will do the same. So for n in whatever 0 to infinity, we'll square the number. So we'll square the n, which is n multiplied by n. And then if n squared is greater than or equal to upper, which is 1000, we say it's break it. Break the loop if exceeds the upper limit. Else if is odd and then n squared, then we'll say something like accumulate plus equals to n squared. Okay, okay. It's nice. Well, what's the usage of it? I don't know. So it's, calculating. First of all, it's getting all the squared numbers. We are not getting n like 1, 2, 3. We are getting n, like we are getting n as 1, 2, 3, but we are operating on n squared, which is not 1, 2, 3, which is like 1, then 4, then 9, then 16, something like that. All right. And as soon as it gets something like above 1000, we break it over there. And before that, like if it's not above 1000, what we do? We say if the number is odd, like 4 is not odd, so we'll not add that 4. So 1 is odd, then 4 is not, then what is it? Then 9 is odd, so we'll add 9 plus 1, which will be 10, like that. So we'll be adding all these odd n squared numbers to accumulator over here, and we'll just then print the accumulator. Simple. Imperative approach, which was step by step, we'll do everything. We'll not use any sort of functionality. Whereas functional approach, well, this looks goddamn cooked right now. So let's sum of squared odd number is of type U32. Then we go from 0 to 0 and then map. Then we use a closure function which gets sort of a n squared from here. Well, and then we are saying that take a while. And then again a closure function where we are saying n squared, and if n squared is greater than upper, well, end it, or how it works, I don't know. It'll take a while or sort of below upper limit. As soon as it goes above upper limit, the take while will do something, I guess. And for filter is something we created. If n squared is odd, which is odd, is already defined over here. So if it is odd, we say sum. It's not, well, it'll get somewhere reduced from here only, or sort of thrown out of this loop from any of these steps. So if it is a squared number which is greater than 1000, we throw that number from here and we break that loop. If it is n squared but it is less than 1000 plus it is sort of not odd, we throw it again from here and we just use the odd values, then we sum it. Well, this is the one way to do it. I wouldn't. I would just use imperative. Yeah. So it's giving us the same result. Obviously, it would. Now, take while is like something already declared, but where? It says go to options and iterate or implement the fair share of HOFs. So these are higher order functions. So Rust provides higher order functions. These are functions that take one or more functions and or produce a more useful function. So HOFs and lazy iterers give Rust its functional flavor. I guess it was talking about this. You can just use map. So it's sort of wizardry, I guess. And this is the range. On range of 0 to infinity, we are mapping n squared, and then we are take a while, we use filter, we use sum, we print out the sum, we directly print out the whole. Oh. This is not a function, this is a variable. Yes, sorry. How can I? And this variable is not even a closure, it's literally variable. Ah, and from closure, I remember like any sort of closure. Where is the closure? I want a closure. So this is a closure, but we are not storing it in a variable. I want a closure that gets stored in a variable. Uh, do I see any? I want to. Example in standard over here. So yeah, let's say this is a text. So I want to ask like what is the type of text? What is it? What is it? Let's write something wrong like U32. And now let's ask what is the type of text? Is it U32 or something else? Tell me what is the type of type of the text. Is it U32? Look at your code, there is a type mismatch. Yeah, I know. I did it. So the text is of type fn.toOwned. No, fn.toOwned returns a string, so it is of type string. This would compile. But this will. So this is of type string, like capital string. This will work. Or simply let Rust infer its type. Well, I want to know what is this type, so I can control it better. Yeah. So it is of type string. I want to see a simple closure like this. Let's create something like it is also of type string and run it. If it runs, it is of type string. If it doesn't, ah, expected. What it says on string? Note expected string. So no spelling mistakes. It found a closure. So closure. I want to know what is its type. Is it a closure type? Like, will I write a closure over here? Will it compile? Will it not? What is the problem? Where did it go? Need the type that I should write for this URL variable, and let's paste that variable. So it is of type function, but we are implementing function. Or if you need a trait object, then it becomes something like this. But no, this looks fine. If I say implement function, then that's the type. Means takes no parameter, returns nothing. Implement function works in most contexts. As for box dynamic function, it is needed if you need to store it in a struct or return it from a function. Well, I'll just try using implement function and function both. And first of all, say implement function, then do this. Let's clear the whole closure topic. It says no, this is wrong. All right, this is wrong. It's not implement. How about just function? Yeah, it works. It is just function. If I say it is, function mute, I shouldn't say it like this, but let's go. Hell, there's another thing like capital M and capital F. Closure is type FN mute. We still get an error. What if we say it is of type FN once? How about that? I just want print statement once. Mutability. Ah, it is also wrong. What if I say just FN, not even small f, capital F? It's still wrong. I can just say something like FN and it compiles. So closure is of type function, which is not a function, but it's of type function. Like this function is of type fn, whereas this fn, not our this fn. This fn is different, whereas this fn is different. All right, so let's move on where we were, higher order functions, and we sort of completed it because there was imperatives approach and there was functional approach, and we really liked imperative approach. But we should learn about functional approach because it is sort of a soul of a language. Map, take while, then filter, and some. All of these are implemented, sort of optimized for these use cases alone. So we can't implement something that's better than these uses. Let us ask something like which will take more time, functional approach or imperative approach? Which will take more time, uh, when we and ch mark wise the functional null ABBROACH. I think functional approach should take the least time because it is implemented by some of the well language makers or contributors, or imperative approach. PERATIV. In Rust, the imperative approach is typically benchmarks faster. Oh my god. Than functional approach, especially in tight loops for performance critical code. This is because the functional constructs like map, filter, or closure can introduce small overheads due to indirection or lack of inlining. Though Rust's optimizer often mitigates this, that said, the difference is usually negligible for most real world application, and functional code can be readable and maintainable. So always, profile your specific use case with cargo bench to be sure. And premature optimization is the root cause of all AI. Oh shit. So if you're optimizing for speed, prefer imperative loops in hot path. Don't sacrifice clarity unless benchmark prove it's worth it. So since it is not worth it, so we'll keep it in our cold blocks. We'll learn it someday, but not right now. And then we are at our last topic. This is our last topic now. Diverging functions. Let's take a bit of break and start. Right? So we'll start from diverging functions. So diverging functions. Diverging functions never returns. They are marked using this exclamation mark, which is an empty type. Oh, so there's a function foo, and it is a diverging function. So we'll say, well, we'll return something like exclamation mark, which is none or an empty type. And then we use a panic macro that we have never used and says this call never returns. So it will not return anything. So we'll see. Oh, it never returns. Oh, then we will not see anything. It's no output. And what's this doing over here? It's telling us that it will return something like uh, exclamation mark. So it will never return. Let's copy this. This seems something trivial. Let's cd into our Rust. Sorry, not Rust. Project learn. Inside that we have Rust. We have something like this. Let's create a different file. Is 6.rs. We paste it. Will this work? Well, it shouldn't because must C and 6.rs. Now what does it say? Says consider adding a main function too. Yeah, that's what I thought. So we'll add a main function to it. Main nothing. What it will return is none of our concern. And we'll just run a function foo or call this function foo from the main. Let's do that. Now try compiling it. Compiles, we get a 6. We say thread main, which was 7567, panicked at 6. This call never returns. So we got nothing, not even a void type. Good. No errors, but not even a void type return. So as opposed, it sort of looked like this. So as opposed to all other types, this one cannot be instantiated because set of all possible values, this type can have empty. This can have is empty. So note that it is different from the void type. Sorry, I always say this void type. It is not void type. This thing is called unit type in Rust. This is not void type. So I have said it multiple times. Please forgive me. This is not void type. This is unit type. All right. So note that it is different from the unit type, which has exactly one possible value. Unit type has exactly one possible value. But this exclamation mark is different from that. So for example, this function returns as usual. Yeah, this returns a void type, nothing unusual over here. Although there is no information in return value, it returns something that is an empty tuple, which is a unit type. Now in a main function, we let a variable of type, again the unit type, and we are calling some function on it, and we are storing that value of unit type over there, and we say the function returns, and you can see this line. So this sort of function returns, and we can see the next line. So let's copy it. Let's make a c.1, c underscore 1. Let's do this. And how would I copy it? All right, and in this, I want to see, like, what does it mean when it says no return? Will it not even return us like this? It shouldn't do this, but let's see. First, we'll compile something like 6.1. So Rust C 6.1 6 underscore 1. It gets compiled, and we shall see some print statements that this function returns. What about 6.rs? It says unreachable statement. So foo, which is any code following this expression, is unreachable. So after that, nothing gets returned. So it doesn't even return to the main function to start or continue what it was doing. So we'll not see any sort of print statement too. That's what it's doing. Yeah. So we don't see anything. That's why it said something like unreachable statement. So this print statement is a unreachable statement. And that's good. That's defining what it is and it was doing. Because earlier we couldn't get what it was doing, or trying to do, trying to achieve. But now we know. Now we know. So as opposed to this function, which will never return. So something like this, it is of type, nothing, empty type. And now we are also saying panic, and then we try print ln, and it will not return. I guess my OBS is well suffering right now. So we'll try to end this as soon as possible. So let's see what it returns. It returns the print statement because this function returns. As for this, it never returns, so we'll never see this print statement as we know. So this return print statement over here, this will not. So as opposed to this function, which will never return the control back to the caller. So it will never return the control back to the caller, which was main x. So we'll never see this. Although this might seem like an abstract concept, it is actually very useful and often handy. Thus, like the main advantage of this type is that it can be cast to any other type, making it versatile in situations where an exact type is required, such as in match branches. This flexibility allows us to write code like this. All right, so we are using that never type truly well somewhere. Where is it? So we have sum of odd numbers, which is well up to, and then which is of type u32, and it will return u32. This is a function. Then we say something like mutable ACC or whatever this is accumulator is 0. We are initiating accumulator to 0, or just like total is equals to 0. For I, from 0 to up to whatever the range is, or sum of odd numbers, whatever the range is, we are going till there. And then we say something like, notice that the return type of this match expression must be U32 because of the type match, because of the type of the addition variable. So there is an addition variable which is of type U32. So match will be like I. Where is I? I from here. And we try to, divide it by 2. It doesn't return 0, it returns 1, means odd. Then we'll say something like true is I, and then false is like continue. Then we return from there, and we add this addition to the accumulator. So because of the type of the addition variable, this addition variable, the I variable is of type U32, which is perfectly fine. All right, perfectly fine. And it is sort of a match statement, but we don't see, there it is. It's a match statement. On the other hand, the continue expression does not return U32, but it is still fine because it never returns. So continue like expression does not return anything like U32, but it is still fine because it never returns. So therefore does not violate any type requirements of the match expression. So continue is of type never, I guess, exclamation mark. So if I said something like, oh, I can't edit it. If I said something like exclamation instead of continue, will that cause an error? I think it will. I hope not. And let's just copy it and we'll create it again. Now accumulator is adding it, and then we are returning the accumulator from this function, which is some order. And then in main function, we are calling some order on 9, and then we are printing, which is excluding the 9. But what if I want, oh, we can't edit it. So last statement says it also returns the type of function that loops forever. So there is loop. Yeah, we have used this sort of never, but I never thought that this never or this empty type would be the same that we use in loop. like network servers or function that terminates the process like exit. All right. So let's first of all, create a 6 3 not rs. Inside that, instead of continue, first of all, let's compile it. So rust c, and then 6 3 not rs. It compiles and it returns perfectly fine. Yeah, it returns 16. Now I want to see some errors. So I want to see some errors. So instead of continue, which it is telling me is of never type, I'll just write never. Now this should give us an error. It does. So expected expression. So while parsing the match, I'm starting here. We can't say never. Good. It's like continue. Right. Now it works fine. And we get everything. Everyone is happy. All right. Get the point. We can't just use exclamation mark over here. It'll throw us an error. And this example or function by Rust by example is completed. So next is our modules, which is again of lengthy, not very much. We'll start from there. Oh, it is. It is. Damn. Struct variables, the use declaration, like use, create, deeply nested. We have used the use declaration, but we have not sort of read it from the documentation. So it will be interesting to see what is there in this document. Super and self. Where's the super and self? It's sort of some sort of concept, not just a function. It is super and self. Good. After that, file hierarchy. So there's a file my, inside that we have rs, outside we have my.rs, and then my split.rs. So module can be mapped to a file or directory hierarchy. Let's break down the visibility example in this file. So we said tree, then this. Now in split.rs, we see something like mod, which is my, this was this one, right? Module is my, function is like print and called function, everything. Then in my.rs, oh, in my.rs, all right. We say module is inaccessible, pub module nested, and we do all these things. Rust split.rs, and we are running it split called my function called this, called that. That was what we were printing. And that's it. After that, we have a crate. Good. And crate. Crate is also done. So crate is short, very short. So I think along with crate, we'll study cargo. So tomorrow we'll study modules. After that, we'll sort of study 11th and 12th together, because they both are sort of very small modules, like two topics, and over here it's 4 topics. There's attributes. Attributes has only 3 topics, and generics, well, generics has 9 topics, 9 subtopics. Well, we are reaching our goal of 24. We have reached 9. So there's 15 left. So 15 modules left, including 10 to 24. So 15. Let's end our stream. And it was also causing some sort of error. See, let's end it. All right. Bye, bye, bye.